Welcome back, everyone. So before going to the nonlinear ODE, we will talk about system of first order ODEs, and those are linear ODEs. So in this video, we will try to find the solution of system of first order linear ODE. So in case of single ODE, we have these three kind of formulations. So suppose the ODE is dy over dt, and that is given as a function of y and time. And if we do the explicit formulation, then dy over dt has the forward finite difference form, that is given as y at n plus 1 minus y at n divided by delta t. And in case of explicit, this will be equal to function value evaluated at old time step. And in case of implicit formulation, this will be equal to function value evaluated at new time step. And in case of crank equation, this will be equal to the average of function value evaluated at old time step and new time step. Now in this case, we have set of ODEs. So suppose there are two ODEs, and those are given as dy1 over dt is equal to f1 function, it is function of y1, y2 and t. The second ODE is dy2 over dt is equal to f2, y2, y1, y2 and time. So in this case, we are trying to find out the solution of system of ODEs. So here we are taking two ODEs. We can generalize this formulation, but we are not going to talk about that. Here we will only talk about solution of system of two ODEs. So let us write down the explicit formulation. So explicit formulation. So what are my ODEs? My ODEs are dy over 1 over dt is equal to f1 y1 y2 t. Second ODE is dy2 over dt is equal to f2 y2 y1 y2 and time. So let us discretize the first ODE since this is explicit formulation. So we have yn plus 1 minus yn divided by delta t is equal to function value evaluated at y1n, y2n, tn. This gives me yn plus 1 is equal to y1n plus delta t, function value evaluated at y1n, y2n, tn. Similarly, y2n plus 1 minus y2 at n divided by delta t is given as f2 evaluated at old time step values. This implies I have y2n plus 1 equal to y2n plus delta t f2 y2n y1n y2n t to the power n. So the algorithm becomes that we have y0 y1 at t is equal to 0 and we have y2 at t is equal to 0. So in the next step 1 and 2, using 1 and 2 directly we will calculate y1 n plus 1 and y2 n plus 1. So this is how I will calculate. So there are some people talking outside, so let them go, then I will discuss about the implicit formulation. But remember that in this case there is no matrix formation. This is a direct formula based calculation. So in one step you will get the value of y1 n plus 1 and y2 n plus 1, and that can be calculated using only old time step values. Now let us go to, so these are my final forms. Now let us go to implicit formulation. The implicit formulation says that I have ODs dy1 over dt is equal to f1 y1 y2 t dy2 over dt is equal to f2 y1 y2 t. So my y1 n plus 1 minus y1 n divided by delta t becomes f1 y1 n plus 1 y2 n plus 1 comma t n plus 1. Similarly, y2 n plus 1 minus y2 n divided by delta t will become f of y1 n plus 1 y2 n plus 1 comma t. Now remember, since these are linear ODEs, then this is for sure that my function y1 and f1 and f2 will be linear. That means what I want to say is that f1 y1 y2 t will definitely be equal to a1 y1 plus v1 y2 plus c1 t, and my function f2 will be nothing but a linear combination of y1 y2 and time. This implies that my this y n plus 1 minus y n will become a1 y1 n plus 1 plus b1 y2 n plus 1 plus c1 t n plus 1